Hey guys, so let's talk about Kubernetes volumes. So in Kubernetes, a volume can be thought of as a directory which is accessible to the containers in a pod. We have different types of volumes in Kubernetes, and the type which defines how the volume is created and its content. The concept of volume was present with the Docker. However, the only issue was that the volume was very much limited to a particular pod. As soon as the life of a pod ended, the volume was also lost. On the other hand, the volumes that are created through Kubernetes is not limited to any container. It supports any, all, or all of the containers deployed inside the pods of Kubernetes. A key advantage of Kubernetes volume is it supports different kind of storage wherein the pod can use multiple of them at the same time. Now, types of Kubernetes volume. Let's talk about types of Kubernetes volume, and I'll walk you through each type, most popular ones. First, empty dir. It is type of volume that is created when a pod is first assigned to a node. It remains active as long as the pod is running on that node. The volume is initially empty and the container in the pod can read and write the files in the empty dir volume. Once the pod is removed from the node, the data in the empty dir is erased. Second, host path. This type of volume mounts a file or directory from the host node's file system into your pod. Third, GC persistent disk. This type of volume mounts a Google Compute Engine persistent disk into your pod. The data in a GC persistent disk remains intact when the pod is removed from the node. Third is AWS Elastic Block Store. This type of volume mounts an Amazon Web Services Elastic Block Store into your pod. Just like GC persistent disk, the data in an AWS Elastic Block Store remains intact when the pod is removed from the node. Third is NFS. Fourth. An NFS volume allows an existing NFS network file system to be mounted into your pod. The data in an NFS volume is not erased when the pod is removed from the node. The volume is only unmounted. Next is ISCSI. An ISCSI volume allows an existing ISCSI volume to be mounted into your pod, which is SCSI over IP, SCSI over IP. Next is Flocker. It is an open source clustered container data volume manager. It is used for managing data volumes. A Flocker volume allows a Flocker dataset to be mounted into a pod. If the dataset does not exist in a Flocker, then you first need to create it by using the Flocker API. Next is Gluster FS. The Gluster FS is an open source network file system. A Gluster FS volume allows a Gluster FS volume to be mounted into your pod. RBD. RBD stands for Rados Block Device. An RBD volume allows a Rados Block Device volume to be mounted into your pod. Data remains preserved after the pod is removed from the node. CEPHFS. A CEPHFS volume allows an existing CEPHFS volume to be mounted into your pod. Data remains intact after the pod is removed from the node. Git repo. A Git repo volume mounts an empty directory and clones a Git repository into it for your pod to use. Secret. A secret volume is used to pass sensitive information such as password to pods. Persistent volume claim. A persistent volume claim volume is used to mount a persistent volume into a pod. A persistent volumes are a way for user to claim durable storage such as GC persistent disk or an ISCSI volume. without knowing the details of the particular cloud environment. Downward API. A downward API volume is used to make downward API data available to applications. It mounts a directory and writes the requested data in plain text files. Azure Disk Volume. An Azure Disk Volume is used to mount a Microsoft Azure Disk data disk into a pod. Now coming on to persistent volume and persistent volume claim. Persistent volume PV. It's a piece of network storage that has been provisioned by the administrator. It is a resource in the cluster which is independent of any individual pod that uses the PV. Persistent volume claim. The storage requested by Kubernetes for its pod is known as PVC. The user does not need to know the underlying provisioning. The claim must be created in the same namespace where the pod is created, as you can see at the top of the screen. This one. Okay. In the above code, we have defined kind persistent volume. We have defined the kind as persistent volume, which tells Kubernetes that the YAML file being used is to create the persistent volume. Name PV0001, name of the persistent volume that we are creating. Capacity, this spec will define the capacity of PV that we are trying to create. Storage, 10 GI. This tells the underlying infrastructure that we are trying to claim. 10 GI space on the defined path. Read write once. This tells the access right of the volume that we are creating. And lastly, path is /tmp/data01. This definition tells the machine that we are trying to create volume under this path of the underlying infrastructure. Now let's talk about creating PV. So you can see on the screen right now how we have created or the codes for the creation of PV. Checking PV. Checking PV can be done by this, this function as you can see on the screen. Describing PV. This can be done by this, as you can see in the screen. Let me quickly go to the next screen. Okay. Now, creating persistent volume claim. Now, as you can see on the screen right now, this can be done and the function is right on the screen. Spec we can check here. So in the above two codes, we have defined kind persistent volume claim. Actually, it instructs the underlying infrastructure that we are trying to claim a specified amount of space. Name my claim 1, name of the claim that we are trying to create. Read write once. This specifies the mode of the claim that we are trying to create. Storage 3GI. This will tell Kubernetes about the amount of space we are trying to claim. Okay, so let's quickly now move to creating PVC. Now, to create the PVC, you can see directly the codes to be used here. Getting details about PVC, again, it is similar to what we did earlier, and it is shown, the code is shown here. Describing PVC, again, as you can see here, describing PVC. Okay. And okay, now going to using PV and PVC with pod. This you can see here on the screen. Here, but just wanted to point out a couple of things about these codes. In the above code, we have defined volume mounts. Volume mounts is nothing but this is the path in the container on which the mounting will take place. Volume, this definition defines the volume definition that we are going to claim. Persistent volume claim. Under this, we define the volume name which we are going to use in the defined pod. So finally, I think we are done with this particular, this particular subtitle. Now we will quickly move to the next topic, and in this topic we would be talking about Kubernetes secret. So secrets can be defined as Kubernetes object used to store sensitive data such as username and password with encryption. We will have more detailed study on this and lecture on this after this. So in the next lecture we would be covering about Kubernetes secrets. Till then I'm taking a pause. Thank you very much.